Welcome all of you. Welcome to GatePro classes. We are an offline coaching center in Vizag, and myself Suresh VSR. I've got 23 years of teaching experience and I've worked in different organizations. GatePro is my own institute, my own initiative. Not a very commercial institute. It's meant for just casual teaching, very informal sometimes. And we have not been very active online. We are not very active in YouTube and all. But we have been online in Zoom and through recorded classes through our app. We had our own app, and through that app, we have been delivering a lot of content. So we thought, let's come into YouTube and just give us a little bit of a glimpse of a content. So I want to just discuss about a small question from GATE 2022 from electronic device and circuits. And I want to see whether you have seen this or solved this question or not. So let me just check your content once. The question says there's a p-type semiconductor and it has been subjected to light and illumination, and that's resulting in excess carrier concentration, excess minorities and majorities both, but you say excess minorities. Now the minorities concentration, or the question is, if you see, this is your semiconductor and this is where light is being incident. This is where light is being incident. Now in this light incidence, if you watch carefully here, the light is incident up to here from the center towards left and right, so that there is generation only up to ln, and the generation is up to ln, and therefore there is also recombination occurring there. Because of the generation, there is also recombination, and they're finally asking you the current concentration here. The current concentration, they're asking you at x equal to 2 ln. That's what the question is. So if you watch out the question, excess minority carriers are becoming 0 at x equal to plus or minus 2 ln, where ln is a diffusion length. The profiles of the photo generation rate and the recombination rate, they're shown. That's what we have seen here. The profiles of the generation and recombination. Recombination is very clearly exponential here. Generation is constant. So for this constant generation, you find an exponential recombination. And the current density is being asked at x equal to 2 ln. They're asking the current density at x equal to 2 ln. They're not asking the current density somewhere here. They're not asking the current density at x equal to ln. They're asking at 2 ln. That's interesting. So if you now watch out carefully, just give me a second. If you watch carefully here, what's happening? This constant generation of 10 power 20, because of the exponential recombination, results in a concentration gradient. There is a concentration difference because of the recombination being exponential. They're asking the current density here, where there is no generation, where there is no recombination. There is no generation, no recombination. There they're asking the current density. So what is the formula for current density? J, Q, diffusion constant into dN by dx. Plus or minus, that depends on the polarity. That's not an issue. So what is your dN by dx? Or what is your n of x? What is your concentration n of x or concentration gradient? The n of x is essentially n naught carriers per unit volume per unit time multiplied by lifetime. So n naught per unit time multiplied by the lifetime. That is at the center. But along the length, it's not at x equal to 0. Along the length, if you see, because of recombination, it is e power minus mod x by ln. So 10 power 20 is the generation rate multiplied by the lifetime tau n exponentially decaying with e power minus x. So what is dn by dx? Derivative of this. And the topic is over. That's it. So n of x concentration gradient, why are you getting? We are getting concentration gradient because it is exponentially recombining. That exponential recombination gives you concentration difference. But the question also has not given the diffusion constant formula. So how do you get the diffusion constant formula? Diffusion constant is L square by tau. So the tau and tau cancels here. When we write for dn here, the tau and tau cancels and ln square and ln also cancels. But don't substitute x is equal to 2ln. No doubt the current is being asked at 2ln, but don't substitute x is equal to 2ln because they're asking at x equal to 2ln, no doubt. No doubt they're asking at x equal to 2ln, but still the recombination is only occurring up to ln. So therefore, given this n naught, given this x equal to ln, if you substitute q into d into dn by dx, ln will be left out. N naught x I'm putting it equal to ln. So this is what will be left out. So by logic, I can see that you are getting the current density. So that means the entire problem is over here itself in understanding n of x. Why is the n of x like that? Because of exponential recombination. Now the same question, let me quickly explain in Hindi once. Maybe because of my bilingual approach, I believe in explaining in Hindi. इस क्वेश्चन को ध्यान से देखिए. एक पी टाइप सेमीकंडक्टर है जहां पे लाइट को फोकस किया गया है. सो गिवन अ पी टाइप सेमीकंडक्टर, एक बीचों बीच लाइट फोकस किया गया है और इस लाइट की इल्यूमिनेशन की वजह से, जो कि सिर्फ -ln से +ln तक है, -ln to +ln, देयर इज जनरेशन, देयर इज रिकॉम्बिनेशन. यानी लाइट का फोकस भी यही तक हुआ, जनरेशन भी यही तक, रिकॉम्बिनेशन भी यही तक. ऐसी स्थिति में यहां पे करंट पूछा गया. देखिए, जनरेशन भी यही तक, रिकॉम्बिनेशन भी यही तक, लेकिन करंट यहां पे पूछा गया. जनरेशन यूनिफॉर्म है, रिकॉम्बिनेशन एक्सपोनेंशियल है. कांस्टेंट जनरेशन है, बराबर जनरेशन है, एक्सपोनेंशियल रिकंबाइन हो रही है. तो करंट डेंसिटी की फॉर्मूला क्या है? द फॉर्मूला फॉर करंट डेंसिटी इज q into dn by dx. व्हाट इज dn? डिफ्यूजन कांस्टेंट. अब इस क्वेश्चन में डिफ्यूजन कांस्टेंट भी नहीं दिया उसने. डिफ्यूजन कांस्टेंट भी नहीं दिया, ना ही dn by dx दिया. We can get dn by dx. How do we get dn by dx? dn by dx we can get it because it is exponentially changing because of recombination. कैरियर कॉन्सेंट्रेशन रिकॉम्बिनेशन की वजह से एक्सपोनेंशियली बदल रही है. सो दैट n नॉट पर यूनिट वॉल्यूम पर यूनिट टाइम इंटू लाइफ टाइम. n नॉट पर यूनिट वॉल्यूम पर यूनिट टाइम इंटू लाइफ टाइम. So that gives you dn by dx. So the common sense is this: the generation that is occurring, just give me a second. The generation that is occurring is n naught per unit time multiplying by the lifetime. ये हुआ सेंटर पे. This is at the center. If you want it, मतलब कहीं भी चाहिए तो एक्सपोनेंशियली डिक्रीज होती है, उससे dn by dx आती है. वो dn by dx सब्स्टिट्यूट कर लो, डिफ्यूजन कांस्टेंट सब्स्टिट्यूट कर लो, तो काफी कुछ कैंसिल हो जाएगा. ओनली थिंग इज x इक्वल टू 2ln मत सब्स्टिट्यूट करो, क्योंकि हमें करंट तो 2ln पे पूछा उसने, लेकिन हमें चाहिए रिकॉम्बिनेशन जहां तक हो रही है वहीं पे. तो रिकॉम्बिनेशन सिर्फ ln तक हो रही है, तो वहां तक हमें करंट चाहिए. सो गिवन द करंट अप टू ln और द रिकॉम्बिनेशन occurring up to ln, I substitute x equal to ln. That simplifies and that gives the answer. यानी 2-3 स्टेप्स में आंसर आ जाएगा. द रीजन, एक क्वेश्चन करने की वजह क्या है ना, मैं ये बताना चाहता हूं कि गेट का कोई भी ऐसी क्वेश्चन होती है जो काफी सिंप्लिसिटी के साथ, मतलब सही तरीके से करो तो काफी जल्दी सॉल्यूशन आ जाती है. मतलब सॉल्यूशन के लिए आपको ज्यादा कुछ स्ट्रगल करने की जरूरत नहीं है. सही स्टेप्स लगा लो तो शायद 2-3 मिनट के अंदर अंदर हो जाएगा. The right steps will give you the right solution. So just wanted to show you this, students. Myself Suresh VSR. I've been educator for the last 23 years, teaching in different institutes. have been popular in electromagnetics for antennas and waveguides. अभी भी freely available है. YouTube में कहीं भी सर्च मार लीजिए VSR सुरेश, तो एंटेनास, वेवगाइड्स, काफी इंटरव्यू गाइडेंस, इलेक्ट्रॉनिक्स में काफी वीडियोस है मेरे, 170 के ऊपर हैं. तो यू कैन ऑलवेज फील फ्री टू वॉच देम. बट दिस इज माय ओन इनिशिएटिव. गेट प्रो मेरी खुद का इनिशिएटिव है. तो मैं ऑनलाइन में रिसेंटली, आई मीन ऑफ लेट, आई एम ट्राइंग टू बी एक्टिव अगेन थ्रू यूट्यूब एंड ऑल. बट ये क्वेश्चन इसलिए क्योंकि हम लोग क्वालिटी दिखाना चाहते हैं. वी वांट टू शो व्हाट क्वालिटी वी एक्चुअली हैव. सो दिस इज आवर इनिशिएटिव. डू डाउनलोड दिस ऐप. हमारी ऐप डाउनलोड कर लीजिए, क्योंकि हमारे पास लाइव क्लासेस भी हैं, रिकॉर्डेड भी हैं, ऑफलाइन भी हैं. रिकॉर्डेड इन द ऐप एंड देयर इज लॉट ऑफ फ्री कंटेंट आल्सो. तो जूम में भी आ सकते हैं, रिकॉर्डेड में भी आ सकते हैं, या आप ऑफलाइन वाइजैक भी आ सकते हैं. वाइजैक इज अ ब्यूटीफुल प्लेस. सो यू कैन डाउनलोड द ऐप. ये हमारे ऐप है, चेक कर लीजिए कंटेंट एक बार. स्कैन द QR कोड, इट डायरेक्टली टेक यू टू द ऐप. So do download the GatePro app and scan the QR code. We'll always be there with your students. So thank you once again for supporting GatePro for the last 1 year. Hope your support will continue, and we'll also be more active in YouTube, coming out with more quality content. See you next again with such bits and such critical questions in Gate students. Goodbye.